Welcome to my presentation on the chain rule. The information covered in this video is based off of section 2.5 in the James Stewart Calculus textbook. The numerical examples here will be different, although the concept and techniques used here will be the same. So what is the chain rule? The chain rule is a technique that we use when we want to differentiate a function. A function that is differentiated through the chain rule is one that is really made up of smaller equations. So rather than a simple f of x, we are now differentiating a function that is f of g of x. So in this example, I will reference the function f of g of x as capital F of x. And for most of my presentation, I'll be using numerical examples to hopefully make the information a little bit more clear. But where should we begin differentiating capital F of x? In this case, capital F of x is equal to 2x squared minus 5, and the overall equation is squared. So with this, we first want to break down capital F of x into its lowercase f of x and g of x. This is done because, once again, capital F of x is representative of f of g of x. So for this, we will first want to look at lowercase f of x. And for the chain rule, lowercase f of x is going to be the outside function. A simple way you can usually spot lowercase f of x, or the outside function, is that it will usually be outside of the parentheses in the equation. So in this, the outside function is simply the squared symbol. So to continue, we will write lowercase f of x as being x squared. The x in this x squared is more so a placeholder for another part, but that will become more evident later. After finding the outside function, our job becomes pretty easy. We now look for the inside function, or what is inside of the parentheses. In this equation, this will be 2x squared minus 5. So now that we have identified the various parts of our function, we can actually move forward to differentiating. Again, our main goal is to find the derivative of capital F of x. And to do so, we will need to know the equation. Using the lowercase f of x and g of x we just found, we can now see that the first derivative of capital F of x is equal to the first derivative of lowercase f of x, with g of x inside times the first derivative of g of x. This original g of x inside is what the x of the first derivative of f of x was representative of before. But with this, knowing this equation, we can rewrite our lowercase f of x and g of x as well as each of their respective derivatives. X squared differentiated becomes 2x, and 2x squared minus 5 becomes 4x. Once we have all of these individual parts, our job becomes as simple as placing them into the equation shown at the top. So the derivative of capital F of x is equal to 2 times 2x squared minus 5, which is then multiplied as a whole by 4x. This can then be simplified a bit by actually multiplying the 4x in to get 8x times 2x squared minus 5. This could then be further drawn out by more multiplication, but we will choose to leave it at this for simplicity. It is important to note that for this, when dealing with lowercase f of x, we're not actually creating an x value, but the x is more so a placeholder for the inside function. That is why it appeared to disappear in the final answer. Although we can often see the chain rule as it was used in the function just presented, we'll also often see the chain rule in trigonometric functions. These are functions such as sine, cosine, and tangent. Again, say that we wanted to differentiate sine of x squared. We would first have to find the outside function, lowercase f of x, to be sine. Then we could identify the inside function, g of x, as being x squared. With these set, we would then differentiate sine to get cosine, and find the first derivative of x squared to be 2x. Once we have found that, we could then simply move forward by placing them into the equation we had previously found. This will produce the final result of 2x times cosine x squared. Now we move on to a mini quiz on the chain rule. So for this, I would ask you to find the lowercase f of x, the first derivative of g of x, and the first derivative of the overall function, capital F of x, which is 5x altogether cubed. I'll briefly scroll and pause on the first example of the chain rule to remind you of the equation used. Here's the equation. Another way to think of it could be as the derivative of the outside function with the base inside function times the derivative of the inside function. Feel free to pause here if needed, and I will now move forward to the answer. So first, we would need to identify the outside function as being the cubed function. We can simply denote this as x cubed. Then for the second question, we would have needed to find the inside function to be 5x. And from there, we would be able to identify its derivative as simply being 5. Finally, we could enter this information while knowing that the outside function lowercase f of x's first derivative was 3x squared into the base equation and find the answer to be 15 times 5x squared. Finally, I'll cover one more use of the chain rule that is slightly more complicated and rather unlikely to be seen, but just in case. So for this, we are going to look at the equation capital F of x is equal to sine 5x, which is as a whole squared. By using the methods we had previously used in this presentation to find the inside and outside parts of the function, we could see that the lowercase f of x, which we know as the outside part of the function, which is typically outside of the parentheses, is the square. We can therefore write this as x squared. But when we move on to the inside function, g of x, we see that we have sine 5x. The issue with this is that this equation alone would again call for the chain rule. This is another example of a trigonometric use of the chain rule. So now we will add two more functions to make up g of x. For this example, we will call them h of x and z of x. Again, for this, h of x and z of x are what I'm choosing to name them, but there's no specific set pattern for that. H of x will be the outside function in this instance, as lowercase f of x has been in the past, and that will become sine. Z of x will be the inside function in this instance, which will be 5x. So then we would need to differentiate x squared to get 2x. When we plug this information into our equation for the derivative of a function requiring the chain rule, we will get 2 times sine 5x, which is altogether multiplied by the first derivative of g of x. But we do not already have this, but rather we would have to again use the chain rule to find what the first derivative of g of x is using the h of x and z of x we just found. Using this, we find g prime of x to be equal to cosine 5x times 5. Once we have this, we can finally put the two equations together to show that the derivative of sine 5x as a whole squared is equal to 2 times 5x times 5 cosine 5x. Thank you for watching my presentation on the chain rule.